3, 2, 1. There we go. All right, we're up and running. All right, so lecture 13, P&ID process drawings is what we're going to talk about tonight. And I'm going to start off with just what is P&ID. Has anybody ever seen these drawings? Raise your hands if you've seen these drawings. Well, that's about half, maybe a little bit more than half. So make sure you do have your computer open. You have AutoCAD Electrical booted up because we'll be doing some of these here in a few minutes. P&ID diagrams utilize functional identification conventions when naming the elements present in the P&ID diagram. So what that means is there's lots of stuff here, right? There's a tank here, there's a valve, there's some sort of pump moving some liquid. Maybe there's a heat exchanger, there's all kinds of cool stuff, a rotary compressor, all kinds of valves. But what we're really concerned about is you'll see these valves many times will measure things. So like this will be flow, this will be some sort of flow valve or flow measurement that we'll make. This will be some sort of flow control. This will be some sort of flow transmitter. And you'll see that they all have the same number associated with them. So that is a control loop. That would be control loop number 1. And if I go over to a different set over here, I would see TT, which is going to be a temperature transmitter. TC is a temperature controller. And I can't read the next one, but they're all associated with loop number 2. And you can see how those work as well. You'll also see things like some of them are electrical, some of them are pneumatic. I'm not going to get quite as detailed into that tonight, but I want to at least get these components out there, show them to you, and work with them a little bit. Now, before I go there though, I want to talk, most of what we've been doing up until this point is what I would call discrete machine control. And what does that mean if I say discrete machine control? Yeah, on, off, 1 or 0. So the ladder diagrams that you've been doing have had temperature switches, pressure switches, limit switches, push buttons, right? They've had these things that are either on or off. And those work really good when we're talking about general like machines. You've got a packaging machine. That packaging machine, I wait for a box to get here, and then when it's there, that goes true, and I seal it shut, or I fill it up, or I do these different things, right? The difference is when we get into process-oriented stuff, like my Diet Coke here, if I make my Diet Coke, and along the way, as I've got a kettle that has some sort of reaction that's mixing the components, the syrup and the water and all these different things, right? If I do that at a certain temperature, I don't get Diet Coke anymore, do I? I might get Diet Sludge, or I might get Diet, alcohol or something. I don't know what I'm going to get, but depending on the temperature I do that at, different things happen. So I can no longer use things like temperature switches. I now need to use temperature sensors and transmitters and things like that. So, and you could do this for anything. I could be talking about flow, I could be talking about pressure, I could be talking about temperature, I could be talking about speed, right? All of these things are the same thing, right? But as an example, a temperature switch is a discrete device wired to a PLC input, monitors for a certain temperature, makes changes based upon when that thing goes true. So when I reach a certain temperature, that switch turns on, or when I reach a certain temperature, that switch turns off. And then that feeds my PLC, and I do logic based upon that. The difference is a temperature transmitter, which still is going to have a sensor associated with it, is going to take a reading of the temperature, and it's going to transmit it over a network. All right. Now, it doesn't have to necessarily use like an Ethernet network. There's HART networks, and there's CAN networks. There's all kinds of different networks that we can transmit over. There's wireless networks. Imagine if you're working at an oil refinery where your grounds are over the course of several square miles or something like that, right? Now, all of a sudden, if you want to read the tank temperature on the other end of the plant, you probably don't want to run wires all the way over there, right? So you may at some point have a wireless transmitter. And we've got a great company, local, Emerson, used to be called, well, we still call them Rosemount at Emerson. Does anybody here work at Emerson? Nobody, okay. Anybody in here ever work at Emerson? Usually I get one in the class that's been there, but nope. So Emerson makes these transmitters that look like this, and I actually think I'm not showing an Emerson one. The Emerson ones have a big blue body on them, not just a blue little cover here, but the whole body would be blue. And what they do is they take that temperature reading, they convert it to something digital, and then they transmit it over a line. So we don't want to transmit, we like to transmit digital data and not things like We used to do a lot with pneumatic. We used to do a lot with transmitting a voltage or even a current. What's the problem with some of those other transmission variables like voltage? Losses, noise, all of those are problems, right? You know, so a lot of times we talk about like a 0 to 10 volt analog signal, and we have that thing scaled or proportional to 0 to 100 degrees C, right? Works out really nice. 5 volts is 50 and 7.5 is 75, and you can do that really, really easily. But the problem is when you send that 10 volt signal over a line, Mike's right, we got to make sure we don't have noise affecting that, because if there's noise on the line, I can literally move that thing up, maybe a couple millivolts or down a couple millivolts, and or maybe several millivolts, right? And Andrew Hohn's right too, because in his particular case, if I run a long stretch of wire, depending on the impedance of where this thing's going, the load, I may end up losing some of that voltage over that long piece of wire, right? So we prefer to transmit digital data. So transmitters can be used to measure various process variables, transmit temperature, pressure, humidity, flow, speed. You know, almost anything that we could measure, we can transmit that data. All right. Now this is one that you for sure will see on next week's quiz. I will tell you, these are what we call P&ID process codes. Now, kind of like UL 508A that we talked about, what did that deal with? The UL standard. Yeah, control panels, wiring up of control panels and things like that. Yeah, so now ISA 5.1 is another standard that we deal with. ISA 5.1 is the instrumentation symbols standard. So ISA 5.1 defines the use of instrumentation symbols to describe process variables, device types, and associated loop numbers. Now I will tell you ISA 5.1, and you can look it up, and I think I even posted a copy of ISA 5.1 in this week's Canvas for this week. So if you want to pull it up, there's a PDF. It's a lot more complex than what I'm showing here, okay? So don't think that this is all of ISA 5.1, because it's not, all right? But this is the general way it's done, the general way it's used, and just some of the things that we can play around with, but there's many, many more. So the first letter is going to signify our process variable. So like F is flow, P is pressure, L is level, S is speed, T is temperature, and W is weight. And I think there's actually like 30 or 40 letters that are available to us. It's not just limited to these 6, right? Then the second letter is going to tell us our device type. And also, by the way, in ISA 5.1, you can have more than 2 letters too. So again, realize this is a little simplified model of what we're talking about, but very, very true to this day. So the second letter is going to be the device type. So I can have a controller, I can have a recorder, I can have a switch, I can have a transmitter, I can have a valve, I can have a relay, or I can have an actuator. These are all the different things. And then what's going to happen is you'll see these bubbles or circles that will be associated with your process. So FV07 is going to be my flow valve on loop 7. Okay? TT13 is going to be my temperature transmitter on loop 13. And PS1 is going to be my pressure switch on loop 1. And all I have to do is go back and say, okay, what is that thing? Okay, that's what it is. You know, it's a pressure, it's a switch, and it's on loop 1. And it's not uncommon to, on one of these wires or one of these transmitters or one of these devices, to actually have a tag. Sometimes they're metal tags that are attached to the cable itself, and it'll actually say FV07 right on the cable. And you'll know that that's what this instrumentation is doing. It is the flow valve in loop 7. And why is that important? Because if you're out in the field and this transmitter is, you know, half a mile away from the process or from the SCADA system that's monitoring it, it'd be real nice to know what it is I'm looking at, and I can break out a set of prints and look and see what is FV07, right? Rather than trying to guess or, God forbid, try to trace it back. You know, that would be even worse. All right, so what we're going to do is we're going to do a demonstration of a fairly simple P&ID diagram or drawing. So what I'm going to do is I'm going to go into my AutoCAD Electrical, and I guess I'm okay. Here guess I don't want to open that. That's actually one of my old ones there. Let's see. All right, so I'll do a new drawing. You guys can all do a new drawing. Let's call this, I'm sure I already used it, P&ID. I'm going to call it Demo 2. You can just call it whatever you want. Make sure you attach your template on this new drawing. And hit OK. What's that? Yeah, I don't have one of the new ones, so you guys have the new one. I got to make one of the new ones. You are correct. All right, so now I've got my template open, and yours looks something like mine. You might have a better scale on yours. The other thing I would do is make sure that your snap mode is on. So snap mode is what? F9. Very good. What does snap mode do? Yeah, it makes sure that your devices are kind of moving around as the grid would move them around versus just having them randomized on the background. All right, so the first thing I'm going to do is across the top of this, and this is a nice trick that I give Mike credit for, I'm going to do a multi-bus across the top of this. So I'm going to click on multi-bus, all right, and I'm going to do 3 wires, and I'm just going to leave all of the defaults the same. So I'm doing multi-bus, and if anybody doesn't remember where that is, it's right next to your wiring tool. Multi-bus. Make sure I have the number of wires set to 3. I'll leave the spacing, vertical, everything the same. And what I'm going to do, though, is I'm going to draw them from the right-hand side of my drawing over here. Oh, what did I do there?
You need to click on empty space. You had it assigned to another bus.
Oh, I did. Good catch. I want empty space, go horizontal. Good catch there, Kim. Empty space, go horizontal is what I want. Now I want to pull them to the side. And I'm even going to do this funky little flare of pulling them up kind of vertical like this to make a little angle almost. So they look kind of like that. And I'm pretty happy with that. I guess I can live with that. So I've got 3 buses up there. And what I'm going to do next is I'm going to zoom in on where these buses come in, or these wires come in. Right at the top left here, this is where my wires come in. And what I'm going to do is I'm going to add a reference arrow to each one of these. So where it says source arrow, I'll go to reference only. And I'm going to do the tail up. I'm going to add one here. And I'm going to call this one, I wrote it too small, I can't remember what it said. So my printout, there's no way I'm going to be able to read that writing right there. So what I'm going to do is I'm going to call this one hot. The first one's going to be called hot. And then I'm going to do another reference arrow. This one tail up again. This one I'm going to call cold. And then I'm going to do one more reference arrow. Tail up, and I'm going to call this one steam. And if I want to, I could move a couple of these around by just grabbing their little handle there, just because I don't like how cold and steam kind of lined up there. So I'm just going to kind of line them up just a slight bit different, just to kind of offset them, so I don't look like a clustered row of letters there. So what I would call this is, I call this kind of like our plant services. If you look in this room, we got a number of services in here. We've got pneumatic air, 125 service air coming in the back of the room. You know, we got 240 volts coming into the room. We got 120 volts. We don't have any water coming in here. We don't have any steam coming in here. But these are the services supplied to us by the building, right? By the plant. You know, maybe there's a compressor. You know, maybe I've got steam available. I've got all these different things. All right, next, what I'm going to do is I'm going to kind of just scroll out a little bit, and I want to insert a few things. So let's do this. Let's go up where the icon menu normally is where we click. I'm going to go to the Insert Components right here. And we worked in pneumatics last week, and we could have worked in hydraulics as well, right? This time we're going to insert P&ID components is what we're going to do. So I'm going to insert a P&ID component, and I'm going to come into here. And what I want to do is I want to get some valves. So let's go under valves. And let's see what I want here. Yeah. Self-contained regulator. These are not actually the ones I want.
Just click on the valves, you might get what you want. Click the overview, yeah. You get the ball valve, gate valves.
Yeah, here, let's grab this diaphragm valve. I like this one here. What I don't want to do is I don't want to have that loop back or the regulator or any of that stuff. So I'm just going to grab this diaphragm valve right here. And go ahead and click on it. And place one right here. And just hit OK for now. Now what I realized is it's coming in at an angle that I don't like, because I'm going to tap my wire off up here, right? So we'll see if it fixes itself. So I'm going to bring a wire down to that valve. So I'll go to my wiring tool, and I'm going to go from my cold line. So wherever my cold line is, and for me the cold line's in the middle. So I'm going to go from my cold line down to here. Yeah, I'm not a fan of that.
And then maybe put the valve in.
Yeah, you know the other thing we can do, let's do this real quick.
Select vertical.
Yeah, how'd you do that?
On that screen there's a bottom, no, you can select vertical when you select a component.
Oh, can you?
Yeah.
Let's do that. I like that better. Let's grab one there. So we'll go back to the components. We'll go back to P&ID.
Bottom left button. You gotta be
Vertical.
careful. It'll stay on, so be careful.
So it'll be vertical for everything now.
Yeah.
So now I want to go back and find that diaphragm valve, but I want to make sure that vertical text checkbox is checked. And then go ahead and grab that same diaphragm. There we go. That's much better. And hit OK. And you know, if you want, let's go ahead and hit OK repeat. Let's put a couple of them in. Let's put a couple side by side. Maybe I'll put 3 of them in. This is not what I did on my PowerPoint, I don't think, but that's okay. So I've got 3 of these diaphragm valves put in. All right. And what I'm going to do is I'm going to wire all 3 of them up. From here to the cold, to the cold, and to the cold. I got to see if that's where I went. I think that's where I went. Yeah. If it isn't, it's too late now. All right, so those are my 3 valves I'm going to have coming in. So now you can see there's lots of components available to us. So I go back into Insert Components, and I go back into my P&ID menu. There are a ton of components I have available to me, right? I've got under Equipment, you'll see fans, compressors, cooling towers, mixers. Under Tanks, you'll see tanks and vessels and different style tanks and heaters. Under Nozzles, I get small nozzles, large nozzles. Under Pumps, I get centrifugal and rotary. I get all kinds of fittings available to me and unions. Valves, I get ball valves and relief valves and check valves. I get actuators that I can call up separately, so I can put in a valve and put a separate actuator on that valve if I like. I also get some of these logic functions. Some of you guys are in Anjana's class right now talking about PID, aren't you? So I can see things like integral. I can see probably a derivative in here somewhere. There it is. So I can call those logic functions as well. Instrumentation, we'll use this in just a minute. Flow and flow arrows. What I'm going to do right now, though, is I'm going to grab a tank. So I'm going to grab this vertical looking tank that's right here. I'm going to place a couple of those guys. Ooh, will it come in vertical?
If you had vertical selected on vertical, so it's not vertical.
So I brought in a vertical tank horizontal because I had vertical selected, right? Very nice.
Double negative.
Double negative. So I'm going to go back in and uncheck vertical, and I'm going to go back into my tanks and grab that tank. Now it's going to come in vertical. And maybe I want to repeat that and put 3 of those guys in. So now I've got 3 tanks in there. It seems to me I ought to be able to wire those guys up, right? I ought to be able to go. Now here's the other thing. If you're not aligned, you can always go ahead and align them too, right? So I'll go ahead and wire this up. That one worked out good. This one looks like it might not be aligned. Actually, they're coming in just fine. That last one is not. Oh yeah, that didn't work out so well. So I'll grab my wire. You gotta go till I find that X. There it is. So I got a little jog there of that wire there. And I guess I'm okay with that. I'm not too, and we should, you know, in addition to doing this, we should also, as we're placing these tanks, we really ought to maybe get a tag on this thing, right? So if this is tank, you know, maybe it's tank 1, and I can apply that tag to it. Maybe this guy's going to be tank 2. Can apply that tag, and I can have tank 3 as well. So on and so forth. So I have tank 1, tank 2, tank 3. You can again move those tags around to where you think you want them, but I think I'm okay right now. All right. So the next thing I'm going to do is I'm going to take all those tanks, I'm going to have them feed a pump. So these guys will kind of keep a head on my pump so that I have something to pump from. So I've got water coming in, filling up these tanks, and they'll keep a head on the pump. So I got to go find a pump. So we'll go into my P&ID components again. And I like this centrifugal pump that kind of goes to the right here. So we'll grab this centrifugal pump 2. We're going to place him kind of right over here. Right about here or so. And maybe I'll just call him P1 for now. I get a chance to tag him, I might as well tag him right now than going back and doing it later on. So now I have that pump 1, I have my tanks. I also want to put in a check valve. What does a check valve do?
Stops backflow.
Stops backflow. So what I'm going to do is I'm going to go ahead and insert one more device in here. So I'm going to put a check valve on the inlet of that pump. So under valves, I've got this nice little check valve right here. And actually I got a number of them. If I drill into that menu, I get check valve 1, 2, and 3. I'm just going to pick the first one and place that guy right about there, kind of in line with where that pump is, and hit OK. Now I'm going to wire all those devices together, and really I'm not wiring. What am I doing? I'm plumbing, really. Yeah, that's exactly right. We call them wires because that's what we're using to connect them. So I'm going to go from this tank into the check valve. Then I'm going to go from the check valve into the pump right there. And then I'm also going to go from this tank down to here and this tank down to here. I'm not a real big fan of how close that check valve wound up to my line there, so I could right click on it and go to scoot. I could scoot it a little bit if I wanted to. I lost my wire there. But I'm happier with where it is now. I feel pretty good about that. There we go. So I've got my pump, I got my check valve, I've got my tanks. I'm going to feed water into this system, and all 3 of these are feeding cold water. The check valve helps guarantee that I'm not going to get flow in the backwards direction. Remember, this is a 2D drawing. I'm not saying that the tanks are up high and the pump is down low. They could be that way, and it probably makes sense to have them that way. But in this case, what the check valve is really doing is once water gets past it, it stays on this side. And if I'm not running the pump, it'll kind of keep a little bit of water sitting there ready to go, too. That's what it'll do. So now what I'm going to do is I want a way to kind of verify what's happening. But before I do that, I think what I'll do is I'll add one more thing here. Under my insert components, I think I can find somewhere in here there's a heat exchanger. Exchangers. So under equipment, you've got these exchangers. What is a heat exchanger?
Like a radiator.
It's like a radiator, exactly right. I've got cold coming in one side, hot coming in the other side, and I'm going to try to put as much of the cold in the heat and as much of the heat in the cold as I possibly can. Exactly right. Sometimes we're using them like in a radiator. We may be using them to cool a coolant down, right? Like in your car, right? Blowing air across that and exchanging the air that, or the heat that's in your coolant for the cool air that's blowing past the radiator, right? In this particular case, I want to go the opposite way. I want to take the cold water and I want to heat it up using steam. So what I'm going to do is I'm going to take this exchanger 1. I'm going to put this guy right here. He's going to go in alignment with the outlet of this pump. You can kind of see where the outlet of that pump is. So I kind of want to be in alignment with that. I'm going to put him right here. Right about there, somewhere in there.
I think now when you make it vertical also, you're like, oh no, that'll be fine, never mind.
Yeah, it does. It's kind of again, it's a heat exchanger, so I guess it kind of depends on which one we're calling the input and which one we're calling the output. But regardless of which way you go, your cold's going to the hot, your hot's going to cold, right? So we are doing the exchange. And then I'm going to go ahead and pull a wire. I'm going to plumb that in. So I'm going to pull that guy over to there. So now I've got my heat exchanger plumbed up. So now here's where it's going to get a little interesting. This is where we want to maybe take a look at a few things. Before I do that, though, let's do one other thing. Under Insert Components, and I don't know why, I got kind of a funky...
Yeah, you overshot it.
Did I overshoot it? I sure did, didn't I? I got a bad habit of doing that, don't I?
No, I don't think it's really finicky.
Yeah. Well, now it looks a lot better. Usually you can see that, though. Sometimes you get these little remnants of wires that show up, and especially if you don't turn off your wiring tool, maybe hit escape when you're done with it, you know, just so you're not, that wiring tool doesn't stay on all the time. This one.
I need to get in the tool crib.
Oh, it's the pink one, I think. That one. There you go. Yep. So there's my heat exchanger. There's my pump. I'm feeling pretty good about that. I want to insert a gauge, so I'm going to go back to Insert Components under P&ID. And now I got to find out where the gauge is. Maybe it's under, is it under no?
Instrumentation looks like.
Is there a gauge in there? I don't see a gauge in there. Flow. I'm telling you, I've done a gauge. That's just a matter of remembering where the darn thing is. Well, while I'm busy forgetting about where the gauge is.
Maybe they're strictly underneath pneumatic or hydraulic.
Oh, we could get one out of there, couldn't we?
We found them there before, yeah, like meters. And...
Oh, you know, I'm going to do that. I think Andrew, I like that. I'm going to go into the meters. So instead of going into my P&ID, I'm going to go ahead and go into Insert Components. I'm going to go into Pneumatic. It's really not a pneumatic gauge, but I want the symbol. So I'm going to go to the... Yeah, I'm going to... it's not really a pressure gauge. It's not really a temperature gauge that I'm dealing with. I'm just going to grab that gauge multiple connections and just place it right here. Call it gauge 1. Yeah, it could be a flow gauge. Maybe it's a temperature gauge. In this particular case, we're just placing a gauge on here to show that we can. All right. Now the difference is, what's the difference between a sensor and a gauge?
Just one read is the readout, right?
Yeah. So a gauge senses something, right? Temperature, pressure, humidity, any of those things, flow. So does a sensor, but a gauge is really doing it for the purpose of us to read it. It's a human readable, right? Versus a sensor typically is not a human readable. Meaning I can't look at a heat sensor and tell you what the temperature is, right?
Old school human machine interface.
Mm-hmm. Old school HMI, I like that. Now here's what we're going to do next. What we're going to do next is we're going to go to Insert Components, and we're going to go to P&ID. This is the part that's not trivial that we want to make sure we get. So even if you're falling behind or not sure what you're doing, make sure you're doing this part. So under P&ID, we're going to go to instrumentation. And under instrumentation, I want to go to discrete instruments. All right, so now what you're going to get in here is you're going to get primary location, you're going to get field mounted, auxiliary location. I'm pretty much just going to use field mounted for all of these, so I'm not going to worry too much about primary location versus auxiliary location. But I'm going to grab this field mounted instrument. All right. And what I'm going to do is I'm going to place that field mounted instrument right kind of underneath the output, like right over here, kind of right next to my pump, but right about here. All right. And then I'm going to hit OK. And I can kind of see where that's at. I like it. It looks pretty good. I'm going to go ahead and put 2 more in there. I'm going to put a total of 3 in here. So I'm going to go ahead and put in another one. I should have just done a multiple, shouldn't I have? So I'll go back to instruments, discrete instruments, field mounted, place. I'm going to hit OK, repeat. I'm going to put 3 of them right there. So I've got 3 of these field mounted instruments. Now I can't remember what I called them. Yeah, my drawings are really, really small. So, all right. But what we do know is going back to our PowerPoint, there are different things I could measure. What might I measure coming out of a pump? Pressure, flow, any of those things, right? So those are all good things to measure, right? So let's say I want to measure a flow. So maybe I do this flow transmitter. So I'm going to go to FT. So I'm going to go right here. I'm going to double click on it. You see you get tag part 1, tag part 2. Why? Because we have 2 pieces we're concerned about, right? So I'm going to call this FT for flow transmitter. And under tag part 2, I'm going to call it 01. Why am I calling it 01? It's the first loop I'm dealing with. I'm going to call it loop 1. Flow transmitter 01. Now when I apply this, what you'll see is that guy right there, it says FT01 on him. All right. I actually kind of like the ones with the line in the middle, but that's fine. Field mounted FT01. Now I might go back to my PowerPoint and say, well, what else could I do with flow? Is there anything else I could do? Could I control flow? I could do that, couldn't I? So I'll go back into here and I'll go into this next instrument and now I call it FC 01. That's exactly right.
If you use a tag when you first put it down too.
What's that?
If you use a tag when you first put it down, you can put that right in that line.
Oh, really?
Yep. It separates the first two and the rest, I guess.
You guys show me on the next one I put in.
Yep.
I'm only going to use these 2. I got rid of the third one. So the idea is maybe in this particular case, I'm going to go ahead and just measure, transmit, and control the flow. Now what that means is I'm measuring the flow at the output of the pump, right? That makes sense, right? So what I'm going to do, I'm going to wire up from here back to here, and then I'm going to wire up from here back to my pump. And I wish I could come up to, I'm just going to go to there. That's not the way I'd like it.
There's ones off the top. We should have gone off the top, I think.
What was I thinking, huh? So going off the top, I think Mike's right. Going off the top might have been a little bit handier, because I do want to kind of show that, and that's no big deal, right? We know how to fix this. We can grab these 2 guys like this. I can drag both these guys up. I do want to put the transmitter down first, though, so I'm going to go ahead and grab the transmitter. I want to put it underneath, and I'll put the controller on top. So FC will be up high, and FT will be down low. Something like that. I'll get pretty close here. And now when I wire this guy up, what I'm going to do is I'm going to go ahead and go like this. From here. I'll go back up.
Turn off snap and you get it.
Oh, will I? F9. Where's my F9? There we go. And, you know, I really should either pull these apart and put a line in there, or I could even scoot them a little bit if I want to scoot it down a little bit. So I could get them a little closer together. Now, I will tell you, I actually wish that those were not genuine lines. I mean, I guess I'm okay with them being lines like that, but they could be dotted lines depending on what it is we're feeding back. They could be lines with a slash, you know, stating that it's an electrical symbol or a pneumatic symbol or whatever it happens to be. But for all I'm doing right now is I'm showing a loop where I'm transmitting this data and I'm controlling the pump based upon what I'm measuring. Does that make sense? That's really all this is showing. It's saying, hey, this is a control loop right here for that pump speed. Now let's go back over to this heat exchanger. This heat exchanger right here has cold water coming into it. And so what I'm going to do with that heat exchanger on the one side is cold water, but coming in from the top, I'm going to bring in my steam. So my steam is actually the third one, which goes to the bottom line here. So I'm going to go to the bottom line is going to be my steam. And so what I'm going to do is find that bottom line. Oh, it's like barely fits on the screen the way I got set up. I'm going to go wire that heat exchanger up to my steam. Just like so. So you guys can see how my heat exchanger and my steam are hooked up. Sure. Give myself a little room there.
Now we need a condensate line and a condensate trap.
Yeah, so now we need some place for that steam to go, right? So it's not going to be enough for that steam just to end up going to nowhere. So I can come down, and I'm going to kind of make it kind of cheesy there, Andrew. I'm just going to go down with it. And I'm just going to put a reference arrow on the bottom. That basically just says, let's see, we'll do this generic arrow down right here, and I'll just say plant. So it's just getting piped back into the plant. Yep. So basically, I'm getting steam from the plant. That steam now is going to flow through that heat exchanger. The cold water is going to pass through the heat exchanger. The steam is going to pass through the heat exchanger. And whatever condensate I get coming out of here is just going to go back to my plant. I'm not as worried about that, but you're right. There's piping, a trap. There's all kinds of other stuff that scuppers. There could be all kinds of things that I have to worry about where that steam is going to end up. All right. Then I'm going to come across a little bit just to the right. So what I know is on this side, I have cold, and I'm actually going to label this. If you go to the Home tab, you can grab this nice little text tool, right? And I'm going to label this line right here. I could just label the wire too, right? But I'm going to call this cold. And I'm going to call it, I don't remember what I used. So I'm going to call it like, I'll say 40 to 50. 40 to 50 C. Ooh, I screwed that up.
Yeah, so the text, if you can triple click on it, you can extend it longer. And then,
Is that what I did?
It's
Appears so.
in AutoCAD, if you don't make the box big enough for your text, it'll do some funky things.
All right, so I'm going to write cold 40 to 50 C. Don't do that again. There we go. Now I'm happy. I'm going to drag that down. I'm just going to kind of put that above the line. I want someone to know when they're looking at this. So I've got cold water coming in one side. right? Now it's going to come out of that heat exchanger, and it's going to be, well, I would assume it's going to be warmer now, right? I don't know what temperature it's going to be, but let's pick a temperature. I'm just going to drag a line here.
If it's cold at 50 degrees Celsius, I don't know what the hot's like.
Yeah, yeah, good point.
I don't know.
So let's, so we got to kind of, this is where I should have my F9 back on again probably, huh? So go back to my wiring tool in the schematic, wire.
Probably almost steam, in fact.
Could be. So I'll say it's hot. Maybe I'll say at this point the water's hot. So I'll say, I'm going to go ahead and put another comment here. I'm actually going to see if I can just copy that comment and just bring it over. So instead of cold, I'll just retype in here. I'll write hot. I'll delete that out, and I'll say it's 140 to 150. C. So I use steam to turn my 40-degree cold water into 140 to 150 C hot water, which doesn't make any sense because I had hot water to begin with, didn't I? So that was probably...
That might be where it's coming from.
Yeah, maybe I didn't have hot water. Maybe this line up here wasn't hot. Maybe it was just pressure. Maybe this was air.
It's kind of lukewarm, maybe.
You know, maybe this was 125 PSI air. Maybe I didn't have hot water available to me, so I'm making hot water, right?
There we go.
Because I had air up there.
You do have diaphragm valves you gotta actuate.
So I need air, right? So there we go.
Good point.
Good point.
I thought you were gonna use the steam, honestly.
Could have.
All right. So now what I've got is I've got cold water coming in. I've got hot water coming out. I'm feeling pretty good about myself. The next thing I'm going to do is I'm going to come a little bit further, and I'm going to come to a valve of sorts. Let's go into my insert components, and let's go find a valve. So now under valves, I'm hoping to find a nice little three-way mixing valve. You know, I thought I saw it initially when I was in here.
You gotta go into like special valves, I think.
Oop, I just saw it. There's a three-way plug valve. It's not the one I was looking for, but angle valves. Oh, here we go. Three-way valve 1. So right when you first click on valves, it's kind of right, it's right here, three-way valve 1. There's also three-way valve 2, and there's also a four-way valve. What's the purpose of a three-way valve?
Mix three things together.
I can mix things together, can't I?
Okay, that's different than I think.
Yeah, so I'm going to put this guy here, but I really want to flip him over.
You could also use it, I guess, like you to split things in the...
You could split things apart
A
too.
lot of times you go in the center and then out either one of it.
Yep.
Only one of it.
Absolutely. Like you think like an airline you might do that with, right?
Hydraulic.
Or hydraulic as well, yeah.
Yeah.
I want to see if I can flip this component. So what I did was I placed it.
Drive a vertical.
I'm going to go ahead and do the flip component and see if it'll flip. No, it didn't help me.
You could just get the valve 2 in there.
Is that why they had a valve 2 in there? Let's go check it out.
Well, do you want 90 degrees or 180?
I want 180.
Okay, so you want to point it up.
I want to point it up. So, yeah, valve 2. Somebody was watching. I like that. Valve 2 points it up. I like that. It's nice that they gave me that. And I'm going to give myself a little bit of room between him. Actually, I'm fine. I'm going to just kind of put him right here. And I can go ahead and put a tag on it. GVA 1. Hit OK. And if I want, I can go ahead and maybe delete this line because I can go ahead and wire him up then. So I'll just delete that wire and go ahead and put a new one in that goes all the way across. What I will tell you is my drawing's getting bigger than I really would like, but that's okay. All right. Then on the top of this, I'm going to do something else here. I'm going to say, okay, up here, let's plumb this up to cold. So now I've got cold up here. So let's plumb the upper side of this valve to cold. So from right here all the way up to my cold. And we said cold was 40 to 50 C, right? So we know that. So I could maybe grab that tag again that I had down here. Oops, I got my wiring tool on. That's not helpful. Let's get rid of that. I accidentally put a wire in there. All right, so I'm just going to grab that cold tag, Control C, Control V. I'm just going to kind of place him right up here. So I can see coming into my three-way mixing valve, I've got two temperatures of water. I got a 40 degree C and a 50 degree C, or 40 to 50 C, and I got a 140 to 150 C. That means I can do almost anything now, right? I can mix that up in any way, shape, or form. And what a three-way mixing valve does, a lot of these, you can adjust them. So there can be what you're talking about. I can go two different ways. Or if it's truly a three-way mixing valve, I could actually adjust it in the middle. So I could take half and half. Right now, if it's exactly as drawn, I've got half 40 degree water and half 140 degree water. I'm going to get some sort of mix out of that that's in the middle somewhere, right? All right. So now what I'm going to do is I'm going to come out of there, and I'm just going to come out with a wire for right now. Just like so. So now this will be like my mix water. So maybe I'll grab this tag, copy it, paste it, and I'll go ahead and call this mix. Maybe mix temp or something like that. Slide that over a little bit. Pretty happy with that. Now what you might do with something like this is you might say, okay, well I want to find a way to help control this. You know, maybe I want to kind of throttle the cold. You know, maybe I want it hot, but I want to temper that heat down with the cold water a little bit at times. So I could put another valve in here. I could go back into my insert components, and I could insert another valve. Which one did we have? We had the fancy, we had that diaphragm valve. I don't remember where we found that guy.
Yeah, it's on the main valve section.
Right here?
Yep. Third row.
Oh, there it is. Yep. You know what's nice is when you have the line in already, it doesn't matter whether you come in vertical or not, because if I place it on the line, it will affix it the right direction. As usual, I'm not happy with the direction of my diaphragm here. I kind of, my control for this, I kind of wish I could flip it or reverse it. I don't know if I can do that. No.
Yeah, if you flip and then click on it again. Yep.
Flip, reverse component. Flip.
Okay.
And then click on it.
Oh, well,
Oh!
no, you got it working. Yeah, it did it.
It's kind of like asking, are you sure you want to flip?
I did I just do that double negative thing again?
Yeah, you did that. You had it going that way, then you flipped it with that way. So it's
There we go.
It's the right way.
Yeah, so I'm just trying to flip that over so it's facing the direction I like. The reason being is what I might want to do is I might want to take something off of this mix side and maybe throttle this valve based upon what it is I'm doing, right? So like I could come over here now and I could put some instrumentation over here now where I come in and say, okay, and I'm going to use the other one this time. So under instrumentation, I'm going to use discrete instruments, and I'm going to do this primary location just because I like to get that little separator in there. And I'm going to place one of those here. And then I'm going to do OK, repeat. I'm going to place another one right there.
Before you hit OK, click the component tag, so you got your AT. You can put up in the component tag. You can name it, put the number in there, and the name if you want.
So I could
You
do...
separate it, yeah, but it only separates the first two and then the bottom, whatever.
So let's think of what we're getting out of here right now. What are we getting out of there? We're concerned about what now?
Temperature.
We're concerned about temperature now, right? So temperature transmitter, maybe TTO2. So how, you just get the first one though, right?
Yeah, it's TTO2 and just write it.
TTFN top for now.
Oh, there it is, TTO2. I like it. I did the wrong one, of course, but that's pretty typical for me. So I'm going to move this component up. And now I can slide both of them down if I want. Now on this one, if I've transmitted, I also want to control it. So I'm going to click on this one and call this TCO2. And apply it. Okay. And I've got that guy in there. And now I could go ahead and wire this guy up the same way we did the other one. But in this particular case, it's going to wire up to this valve up here. Like so. No, there is a node there though. Isn't there? No, it brings it in from the side there. And that's okay. I think the one that I was using actually had a node. Let me try a different one here. There's a different one that I had that worked a little better.
Actuators.
Ooh, that's exactly where it was. Yeah, it was one of these guys. I'm going to pick this two-way valve fail closed. I'm going to go ahead and put that guy in there. But before I do that, I'm going to delete out this chunk of stuff. And all right, let's do this. There we go. All right, so I'll go back in here. And under actuators, I do have this nice two-way valve. And this one that says fail closed. And I don't know if I want to fail open or fail closed, but I do know I want it to come in vertical, so I'm going to fix that right off the bat. So back under actuators, vertical, two-way valve fail closed. Guess what it did now? Seems like I can never get exactly what I want, right? It doesn't read my mind. But again, I can go ahead and go to reverse flip.
Maybe. It's not working for me.
Is it not?
It's not working.
Is there another one in there? There might be another one in there that faces the right direction.
No, I didn't see another one. There's another one, but it's like...
Well, you know what I'm going to do then? I'm going to use it nonetheless. I'm going to place this guy right here. I'm going to hit OK. And I'm going to go ahead and wire that guy up right from the center here. Oop. I think I actually got to go from the side. Yeah, like right over here. I'm going to go straight down to there. Yeah, kind of messy, but it'll work. And then I want to wire, so I'm going to go ahead and get this, fix all my wires down here now. Bringing up my wiring tool, coming from the top of my three-way valve up into here. And then I got to remember this is going to cold. And cold is the middle one. So I got my wiring tool and go up to the middle one like so. Now you might be saying, well, what the heck are we doing with this stuff? All we managed to do is we managed to create basically what you have in your shower, right? You swing the handle all the way one way, you get hot. You swing the handle all the way other way, you get cold. But now we got temperature transmitters and temperature controllers and all kinds of things that are going to help us to figure out how we're going to use this stuff. And I really consumed a bit of space. But what I could always do, right, I could at this point, if I wanted to take this mixed tank temperature, I could go to another sheet as well, couldn't I? That'd be another thing that would be pretty easy to do. So if I wanted to go, let's say, I wanted this mixed temperature liquid to go to a different sheet. How would I go about doing that?
Source destination?
To do a source destination, couldn't I? So would this be a source or a destination? Source arrow. And I could put a code on it. What do you guys? So they're recommending 600. Yeah, I'm gonna call it mix Yeah, I'm just going to call it mix temp. Maybe mix underscore temp. Hit OK. Now, do I want to insert a matching destination now?
You could do it on the same sheet at the bottom.
Yeah, I could, but I don't have, if I want to, yeah, well, I guess I could actually. Yeah, maybe I will. No, I'm going to wait. I'm going to go ahead and wait. I'm going to hit OK. Now, what about these little arrows? So I called it mix temp, but the arrows didn't actually do anything for me. What should I do there?
Your page doesn't have wire numbers.
Doesn't have wire numbers. Can I put something in there though?
Yeah.
I could, right? I could put in a reference number if I wanted to, and now it has a reference number associated with it. But if I wanted to then go into a different sheet, I'd have to bring up another drawing, right? So I'd start a new drawing. You know, I do a P&ID pneumatic, or not a P&ID pneumatic. What did I call this one? P&ID
Demo 2.
Demo 2. I probably should hit save just to make sure I'm saving. So I'll call this this new drawing. Call it P&ID. Maybe I'll get really funky here and call it Demo 3. You know, just building off of what I've been doing. I'll use my same template. AutoCAD Electrical. Hit OK. Apply my defaults. Now I could, there are some things I did on the other one I could still do on this one, right? But let's say I just wanted to get that mixed temp in here for some reason, right? Let's say maybe this is going into I don't know, some sort of vessel where I'm going to mix it up, I'm going to agitate or something like that. So here's what I'm going to do, kind of playing off the cuff here a little bit. I'm going to go ahead and using my home tab, I'm just going to draw a big square. So under home, I'm going to come in here and draw a big rectangle. I'm going to draw it right here. About like that. So again, I'm not in the schematic tab. I'm just using some of my drawing tools within AutoCAD Electrical. So in my home tab, if I want to draw a rectangle, I can just do it and draw that rectangle in. Now at that point, I still can go, right? I can still go into schematic, go and insert components and find my P&ID components that I want. And I want that funky looking agitator. I saw him under equipment earlier. Oh, I'm not in the right menu here. Schematic, P&ID, there we go. Under equipment, I see this mixer agitator. That's kind of cool. So let's go ahead and grab that guy, place him in this tank. You know, maybe I'll call it Agit 1. Give it a tag. I don't care what the tag is. That's kind of trivial at this point. But now I've got this tank with this agitator built into it. All right, I think my tank's a little bit large, but that'll work. Now if I wanted that line coming from the other drawing where I had that mixed water temp, if I wanted that to come into here, I could draw a wire into this tank, just like so. And I might even put a valve. I might want an isolation valve to be able to use this to fill the tank. So I could go back into my valves and just grab a standard gate valve. Anybody know what's the difference between a gate valve and a globe valve? I see both of them in here. So a gate valve works like a gate, right? So basically, yeah, it's coming in like a flat gate is what it's coming in. And a globe valve is like a ball with a hole in it that rotates, right? And I'm just going to grab a gate valve so I have a nice, easy way to shut this off. But if I wanted to fill this up, I could. Call this GVA 2 or something. Give it a nice tag. But basically, this would be a way I could fill it. Now, I don't have any reference here. But if I wanted to tag that back to that source, how would I do that? Source arrow? Destination arrow. Place that guy right there. And now, is there any way I can do this easy, or is it going to be difficult?
Probably got a project, if it's all the same project.
Recent.
Yeah, there we go.
Look at recent right there. So I don't, again, I don't have a wire number, but I do have this mix type on there. I can hit OK. Now it's saying from question mark, and it's giving me these same question marks here. So if I go back to my other one, oh, where'd my other one go?
Close.
Yeah, it auto-close when you start a new drawing. Don't ask why. You aren't in that project, are you? Is that one active, or are you in test?
Oh, I bet you I'm in test, aren't I? I'm in test. Yeah, you're right. So if I go back and I can open up P&ID. Yeah, I had something going on there. I can open up my demo 2 now. And I did give it a wire number 101. And I've got this 2 question mark. And on my other one, I've got the same thing, right? I've got a wire number and I got a from question mark. What are your recommendations here?
Right click and update, retag update, both of them, or just that one?
Retag update.
Yep.
So it gave me a 101. Now what about these question marks?
Go back to the other one and do it.
So go back to this one. Retag update.
It's not looking for you.
No, but I can double click on these. Can I fix those?
You could write something in there.
What would I write in there though?
Well, you put your other sheet. Oh, you don't have sheet numbers, that's why.
Oh yeah, you're right.
Yeah.
So if I was calling this one sheet 1, or if in this case I'm calling it P&ID Demo 2, I might be going to Demo 3. And if I go, that 101 on the other one is going to go to Demo 2, then I'll go ahead and call this one 2. But now the idea is, so I'm getting that mixed water, and I could even go get that tag if I wanted to, that mixed temp water. I could grab that tag and bring that over to Demo 3. You know, I could paste that here as well if I wanted to. So I know exactly what's coming into this. So now this could be an area where maybe I'm maybe I'm putting a dry product in here. I'm mixing up water with this stuff, and I'm going to mix it. You know,
We built the washing machine.
we built a washing machine, essentially. And if you want to get really funky, you could go into your home here, and if you wanted to be really kind of chaotic, you could say, okay, I'm going to move this agitator up a little bit, and what I'm going to do is I'm going to go ahead and draw some arcs here. Maybe this little 3-point arc. I'll go here, 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 and then I'll copy that guy, Control C, Control V. Look how pretty this is. Yeah, I got like a little, you want to make a washing machine, there you go. Now you truly have your little washing machine here with your agitator and your, yeah, it really messed up my, I guess we're okay. But so the liquid came in there, we mixed in a dry product, and now we're going to have some sort of reaction in here. So I'm making Diet Coke, or I'm mixing whatever I'm mixing up. Now you might say at this point though, are there any instruments we'd be concerned about in here? You know, is the speed of the agitator important to us? Is the temperature of the liquid in here? Is the level of the liquid in here? You know, so there's lots of things I could do here, right? On the outside here, I could have instrumentation associated with, oh, let's see here. Let's go to P&ID, and if we go back and look here, you know, I could say, what's my level? I could have a level transmitter. So I could go ahead and grab another device under P&ID, under instrumentation, and I'll go discrete instruments, and maybe this is a level transmitter that I put right here. So I call it LT03. I think we're up to 3 now, aren't we? Level transmitter 03, and maybe I also have a level controller 03. So I go back into here, and I go under my instrumentation, discrete instruments, and now I'm going to have a level controller 03, LC03. And I'm going to line those two guys up. So I'll go like this. I'll right click on one, click align. Oh, Went the wrong way there. All right, we look pretty good. I might at this point, if I wanted to, I could take these guys and I could wire those guys up, back, and maybe they'd go over here to this valve or something like that. I don't have the right type of valve in here, but we could go back to that valve we were using before, right?
You do have a center reflector on there, actually.
Is there one on there?
Yeah, there's this center one on
This one actually has it? Oh, it does.
there. I don't know why. I don't know why that other one didn't. I don't need that.
Ah, now I got my stuff all messed up here. So here we go. Let's get rid of this. There we go.
I like it though. Oh, wow.
Did it not like
I
it?
didn't like mine.
Mine actually appeared to work there for a minute. Let's try that again. I can also come out the top here too. Ah! My wiring tool is just giving me a hard time here today.
Oh, it's because the valve isn't, their center point isn't their center point. Oh, that's stupid.
Oh, it didn't do it, did it?
No, it's because their center node isn't in the center. So when you put it in, it doesn't.
It kind of does a little goofiness on you there, doesn't it?
In the block settings, when they made it so that way the wire would connect from that direction. So if you if you flip it over, then it'll come in from the top like you want it here.
So should I try a flip on that guy?
Yeah, give it a 180 on the.
So flip reverse component. Flip.
I believe that will do it. And now it should have just flipped it upside down, so hopefully it just connects to the top now. It still didn't quite flip, I
Flip
guess.
the other way, yeah.
Maybe try reverse. Maybe that's how it's interpreting it.
It might be. Let's try reverse. See how that works. No luck? We may have to switch valves altogether for this one, huh?
I don't know
Yeah.
if it worked for me then. 'Cause it,
You know what I'm going to do? Watch this, guys. This is going to fix it. So what I'm going to do is I'm going to get rid of all these wires.
actually, try coming from the valve up, because that's what I did.
Did that work?
It worked that way when I came from the valve up.
Well, the other thing you can do is I could go this way, couldn't I?
Oh, also, yeah.
I'm going to cheat here. And boy, does that work nice, right?
Right around the bottom.
Yeah, so come across the bottom there. All right. So what we're doing is we're essentially showing all the different things that we can do with this, right? You know, you could at this point insert all kinds of stuff. I could run a wire from the bottom down here. You know, I could put in things like a drain valve if I needed to ever drain that tank. I could go in and go to insert components. I could go grab another valve. You know, grab a gate valve and I can put it right here, and this could be a drain valve for my tank. You know, so there's really no limit to what you can do as far as what's going on here. So, make sense? Big things. Some new terminology for you guys with ISA 5.1, which is all your instrumentation symbols. They describe these process variables, they describe the device types, and these loop numbers. Let me look at the homework and give you guys an idea what that looks like for this week, because I don't know what I asked you to do on this. I think I drew a nice picture for you though. I do remember doing that. There it is.
You did draw it.
I did draw a nice picture. All right, so let's read through this here.
You do know we have AutoCAD Electrical, right?
I do know we have AutoCAD. But if I draw AutoCAD Electrical, then I've already done the homework for you. So, all right, so process drawing, 10 points. Your lead controls engineer has to develop a P&ID drawing that represents the drawing above as accurately as possible. Variables in red should include process identification tags such as level, temperature, speed, etc. All components and process tags must be correctly identified. And then the second part of this, worth 10 points, is PLC inputs and outputs. In addition to laying out the process, you must also select the appropriate PLC I/O modules and I/O points shown. This will be a second sheet in your pack. So the grading rationale, correct P&ID components, process tags, P&ID drawing neatly laid out, accurate P&ID drawing sketch, reference arrows used to identify process services, I/O voltage, etc. Dunwoody template, title block, Both drawings on 11 by 17, properly folded, presented, correct PLC I/O devices. So now, it talked about things in red. So the variables in red should include process identification tags. So what that means, yeah, we pretty much did all this stuff. Very similar, didn't we? So in this particular case, you're going to see that these are your process identification tags. Pump speed, control, monitor, and transmit. Then up here, we've got a steam temp. So this is the steam temp and pressure transmit. Then over here, tank level. Oh, this is different though. We've got tank level, the agitator speed, control, and monitor. And then you see we got a bunch of other stuff. We've got here's some stuff for you there. So there's a vapor compressor here with water vapor coming out. There's 2 limit switches in here. Why are there limit switches in here?
Probably just in high levels and low levels.
Yeah, so we can fill it up or drain it off if we need to. And it looks like what they're doing is they've got syrup coming in on one side. That's going through, it's getting heated up, and then it's getting mixed up here. So they're probably going to fill this tank until it reaches this point. And then they can run this agitator. And then when they're ready, they can open up this valve and send the syrup concentrate out. Because what they're actually doing, right, is they're heating that syrup up, aren't they? Is what's going on there. Agitating, apparently we get some vapor when we do that as well. And then we can send off the concentrate. Your PLC I/O, so 2 drawings. You'll have one drawing with P&ID that looks like this, except a lot neater than my fancy red and blue pen. And then you'll have a separate drawing with your PLC I/O. So you'll insert a proper PLC input-output module. Either you could do a discrete input and a discrete output, or you could do a combination module if you can find one that has at least 7 inputs and 4 outputs, right? And you'll see what we have for our inputs. We got our pump start, our pump stop. So that's what turns that pump on and off. We got our agitator start, our agitator stop, same type of thing. We've got a steam temp switch, a tank low and a tank high float. I don't think I actually show the steam tank temp switch on here, but I do show that we're going to monitor and transmit the steam temperature with our instrumentation. And then I have output, the steam valve. So this is my, here's a steam valve right here. I also have a syrup valve. Looks to me like this is going to be my syrup valve right here, right? I have an agitator motor as an output, right? And then I also have a pump, which is right here as well. So that's how all of those things are going to work and run. Does that make sense, folks?
Mm-hmm.
What do you think? Not too bad?
Pretty good.
Yep. So I also included in this week's Canvas, the other thing that you'll see in there, if I can pull it up real quick here.
You guys still want to talk to me? Homework isn't in there,
No,
though.
homework, I'll put that in there when you guys are on break. Yeah, I didn't put it in there yet. I was going to redraw my fancy drawing, and then,
Class tonight?
yeah, probably not going to do it. But the ISA 5.1 instrumentation symbols and identifications PDF, that is in here. So you can, if you want to take a look at that, you'll see it's a lot more detail than just what we did tonight, right?
Yeah, it's ways before you can get to anything.
Yeah, there's a ton of stuff in here. There's a bunch of prefix stuff, but it's going to get down to where it's going to start talking about these letters.
Yeah, you can only have like 15 after the first. You can have one first one, but then 15 after.
Yeah, they get pretty complex. But here's kind of what we're talking about, right? Yeah, so these are some of the letters. Now, I only showed you guys a few of these letters, right? But like under this first letter, let's just look at that one. Flow, that's one we did, right? Temperature is one that we did. I don't know what else did we do. Did we do like a pressure maybe? But yeah, you can see the different letters, and then there's a whole bunch of letters that can come after that too, like Mike's talking. I already lost it, but there's a whole bunch of letters that can come after that too, and then it talks about loop numbers and all these other various aspects of the instrumentation side of this too. So just know that that's in there. There may be some homework. There isn't any homework questions related to it. I will tell you the most that I'll do for the quiz is I might ask you the ones that we've used. I'm not going to ask you to memorize all the letters. I mean, a ton of letters in there, right? But I would make sure the standard ones, flow, pressure, level, speed, temperature, those are the ones that we've kind of played with. And then things like controllers, transmitters, those are some of the things we've played with as well too. So, make sense?
Do you want to show the linking that I figured out?
Yeah, I'm going to go ahead and pause the video here. Alt R.